Okay, in this video we're continuing with naming chemical compounds, but we're going to focus on naming ionic compounds that involve transition metals. Remember, your first step in naming compounds is to determine what your elements are. Are they metals, nonmetals, transition metals, or polyatomics? So if you have something with a transition metal and a nonmetal, you're going to have to follow the rules of transition metals. But this is just like our other ionic compounds. This is still an ionic bond with a transfer of electrons. So I'm going to have a cation with a positive charge, which is going to be my transition metal, and then I'm going to have an anion, my negatively charged nonmetal, because my transition metal is going to want to give up an electron to my anion. So my anion is going to have a negative charge from picking up that electron given off by the cation. Okay, so transition metals, the reason they're called transition metals is because they don't have a single set charge that they're going to adopt or become when they form this ionic bond, when they transfer their electrons. They actually have multiple charges that they can become or that they can adopt. They can become many different ions. So we don't automatically know what charge they're going to take. We actually have to work backwards and figure that out. So let's take a look at some examples. So my FeCl2, iron is a transition metal. I look at my periodic table and there's no charge over that group. So I have to work backwards. I do know, however, that in FeCl2, if I look at chlorine, I'm going to notice that chlorine has a -1 charge. Well, I don't know what my charge on my iron is, but I can actually work backwards to figure it out. So if each of my chlorines has a -1 charge and I have 2 chlorines, I have an overall charge of -2 from my chlorines. And since this is already in symbol form, I know it's already balanced. So all I have to do is figure out what the charge is, knowing that this is a neutrally charged compound. So if I have chlorines, if my chlorines are providing a -2 charge and I only have one iron, that one iron has to balance out that -2 with a +2. So the charge on my iron must be +2. So to name this, the trick in naming transition metals is that I have to communicate exactly what ion my transition metal is forming. So to name this, it's actually going to be iron, and to communicate what ion my iron is going to become, I need to write the charge of my iron ion in Roman numerals in parentheses. So this is iron 2, because my iron is going to have a +2 charge, so it's going to be iron 2 chloride. Okay? Down here I have H2O, so I have mercury and oxygen. Oxygen, I look at my periodic table and it has a -2 charge. Well, I only have one oxygen and it has a -2 charge, but I have 2 mercuries, and all of those mercuries together need to bring a +2 charge to balance out my one oxygen. But I have 2 mercuries, so that must mean that my mercuries each have a +1 charge. So when I name this, this is going to be mercury, and the charge on my mercury is a +1, so it's going to be mercury 1 oxide. And down here, my NiBr3, my bromine, when I look at my periodic table, my bromine has a -1 charge. But I have 3 of them, so I have a total of a -3 charge from all of my bromines. But I only have 1 nickel. In order to balance that out, I need a +3 charge, so the charge on my nickel must be +3. So the name of this is going to be nickel 3 bromide. And I want to point something out really quickly here. So for my NiBr, I had NiBr3. And if you recall the swap and drop method from my naming ionic compounds video, we took the charge that was over our element and swapped it to the next element and brought it down. And swapped it and brought it down. So now I've already essentially done the swap and drop, so I can actually do a quick shortcut to really quickly and easily figure out what the charge is on each of these elements by doing a reverse swap and drop. So let me change colors here. If I take this 3 and I do the reverse swap and drop, so I'm going to bring it from nickel and bring it up, it now becomes a positive 3 charge because nickel is first, so it has to be the cation, so that 3 has to be positive. And down here, my nickel, even though I didn't write it, it has a 1, so I can take this 1 charge, do reverse swap and drop, bring it up to above bromine, and I know that that bromine has a negative 1 charge. So there's 2 ways of figuring this out. Either you can work backwards, because you're always going to know the charge or be able to figure out the charge of your anion or whatever the transition metal is bonded to. You're going to be able to figure out the charge of your transition metal by working backwards from the charge of whatever it's bonded to. So you can do it that way, or you can do your reverse swap and drop. You can take your number, bring it up, and it becomes the charge on your transition metal. Take the number of your transition metal, bring it up, and that becomes the charge of whatever it's attached to. So 2 methods to go from symbol to name. Okay, just don't forget your Roman numeral goes in parentheses right after the name of your transition metal, and it indicates charge. It doesn't indicate how many irons you have. I only have 1 iron, but it's iron 2 because it's an iron 2 ion. It's an iron with a +2 charge when it forms an ion in this compound. And then I finish it off by naming my anion and adding "ide." So now when I need to go from name to symbol, it's actually a little bit easier. Because remember, these Roman numerals are my charge. So my charge for my transition metal has actually already been given to me. So all I really have to do is do my swap and drop, balance the charges, and I'm good to go. So let's take a look at one of these. So copper 2 oxide. That 2 means that my copper has a +2 charge. And my oxygen, I know, has a -2 charge. So if I have copper and oxygen, I've got a +2 and a -2. When I swap and drop, it becomes copper 2, oxygen 2, but I can actually simplify that to CuO. And that's it. That's my copper 2 oxide. My silver 1 bromide, my silver has a +1, and my bromine, I look at my periodic table, my bromine has a -1. So silver, Ag, bromine, Br, +1, -1. So when I swap and drop, it just becomes AgBr. And something to note, you actually won't really ever see silver 1. It'll just say silver bromide. Because even though silver is a transition metal, the overwhelming majority of the time, 99.9% of the time, silver is going to have a +1 charge. While it can very, very, very rarely have a different charge, most of the time it's going to have a +1. So much so that we actually don't even need to have this 1. We can just assume that it's silver +1. So finally, my manganese 4. This means my manganese has a +4 charge. My nitride, nitride is nitrogen, which has a -3. So my manganese, which is Mn, and nitrogen, which is N, I've got a +4 and a 3, so I do my swap and drop, and I get MN3N4, and that is my manganese 4 nitride. So when going from name to symbol with your transition metals, your Roman numeral gives you the charge of your transition metal, and then you can just set it up like a normal ionic compound. Get your charges, swap them to the opposite element, drop it down so that it becomes a number and lets you know how many of each element you have. So remember, these subscripts are numbers. They're not charges. Charges all go up at the top. The numbers at the bottom, the subscript, tell me how many of each of these elements I have in my compound. And again, my compound should be neutrally charged. So follow these rules and tips when you are working with transition metals in your ionic compounds, and you'll never go wrong. Good luck.